There's no lever to press. Electrodes transmit the command directly to the machine. John Chapin heads this laboratory where rats can remotely control machines. He's a pioneer in neurorobotics. His research focuses on developing a brain-machine interface, a technology that marks the beginning of a new type of human, the cyborg, or human robot. But as always, it's tried first on rats, in this case a remote-controlled rat, dubbed the robo-rat. Neurorobotics could take different paths, the brain controlling the machine, or the machine controlling the brain.
So we're just going to go through each one of these arms.
But there's also a third option. A brain could control another brain via the interface. How does this work with the robo-rat? 3 electrodes are planted in specific parts of its brain. 2 electrodes placed in the sensory cortex send stimuli to the area that corresponds to the rat's whiskers. If the rat follows a signal that directs it to turn left, it is rewarded by a discharge in the pleasure center. This discharge produces a release of dopamine, providing immediate pleasure. The pleasure center is also called the reward center.
The feeling of touch really comes from a stimulus inside the brain, so it's a virtual touch stimulus. Now this rat has spent its entire life in a cage and probably isn't going to want to walk down this very, very steep ladder. But we're going to motivate it so that it tries to go ahead and do it.
We too have a pleasure center, as well as a sensory cortex and a motor cortex, just like rats.
Here is the sensory part of my leg. Here is the sensory part of my hand. Here is the sensory part of my face. So there's a whole strip of sensation going from my face all the way down to my legs. Similarly, just a little bit in front of that, there's another strip, and that's the motor side. So this would be movement of my face, this would be movement of my hand, and this would be movement of my leg.
This is the starting point for the working of a cyborg. If one sends an electrical stimulus to the area of the hand, a phantom feeling is created. And in the same way, via the motor cortex, one can trigger an involuntary movement.
Originally we did this because we were interested in people who have spinal cord injury. We could put an electrode inside the brain area that when we stimulate it, it makes it feel like you're being touched on your hand. And so if we had a robot arm, or if we even had little sensors on the hand, when we touch something, when we would actually be able to feel it. We are doing this in monkeys now, and of course to go to the next level and do it in humans means that we have to do several years of studies in monkeys to show that it's safe, to show that it can be done.
On the promising front of neurorobotics, other researchers have already made the jump from rats to humans. The first brain-machine interface tests were carried out in Boston. BrainGate, a computer chip implanted in the brain, allowed volunteers to remotely run their computers with their minds, without a voice recognition system.
I'm going to open the first email, which says congrats. It says you are doing a great job. Next, I'm going to open the second email, which states, hi there. It says, hi, we'll talk soon. Now I'm going to the exit. Next, I'm going to paint a circle. That's the best circle I can do. Now I'm going to exit.
A handful of quadriplegics, like Matthew Nagel, are the only ones prepared to test these still very experimental brain-machine interfaces. They are the ethical gate to neuro-robotics and all its possible civil and military applications.
Now close it.
Now close. Nice. Open. Close. Not bad, man. Not bad at all.
For the human work, it's essentially shown possible to move a cursor across a computer screen. And what we want to do is to have the human brain essentially move a robot arm. It was an interesting situation where a completely different area of science was produced, where we were trying to produce a neuroprosthesis, and here we came out with a guided rodent.
The scope of a discovery's possible applications is always wider and more worrying than the good intentions it may start with. It's not by chance that John Chapin's research is partly funded by DARPA, the Defense Advanced Research Projects Agency. Neurosciences will make it possible to model the soldier of the future.
This is a new deal, gentlemen. Enemy center of gravity is downtown.
Should get a good view from here.
A remote-controlled soldier? One who could download important data into his brain while fighting, who could control his fear and adjust his weapon's firepower with his mind? At this level of technology, everything seems possible. It's only a matter of time, investment, and research priorities. At the dawn of the 21st century, we are witnessing the cyborg's first steps up the evolutionary ladder. At the Japanese telecommunications company NTT, researchers are developing a headset capable of remotely controlling movement. This device sends electrical stimuli not to the motor cortex, but to the vestibular system. It affects the subject's sense of equilibrium and makes him or her veer to the left or to the right. Video game companies are always on the lookout for more realistic gameplay. According to NTT, they are very interested in this type of research. Subjects currently complain of severe headaches after the tests, but if electrodes were placed inside the brain, the results would certainly be more conclusive. We are about to reach a level of technology, a level of control, that still seems impossible today. The great social and philosophical questions of tomorrow will start here, in the laboratories of the brain.
There's no question that we are now at a stage, a revolution in a sense, where we're seeing confluence of insights and technology that are going to propel the science forward at a pace that is really going to be unprecedented.
I think it's just a question of time. People will slowly become educated about the use of brain interfaces, and they will stop worrying about the fact that they have some electrodes inside their brain.
One of the most profound questions in all of neuroscience is whether this powerful new knowledge is going to be so powerful that we cannot control it.
We are such stuff as dreams are made on, said Shakespeare. Who knows whether our dreams will turn into nightmares? The more scientists know about the brain, the more they discover how little is actually controlled by the will, the conscious mind. The confluence of neurosciences, nanotechnologies, and genetics could radically transform the way we live.